All right, part 3 of 3. You guys, this is a really long chapter compared to a lot of our other chapters. We only do 1 chapter a week in managerial, where in financial, sometimes we did 2. So that's why the videos are going to be like a little bit more, but I'll try to still break them up in little bites. So hopefully some of them will be shorter than what we're going on with right now. So, okay, so I relined up everything to make sure things are lining up like with your pages. And so we had just finished in the last one, we had just came up with our 2 cost equations. There's a conversation here in the middle of page 7 about relevant range. Relevant range is your normal operating activity. And so your costs are going to behave normally within the relevant range. And when I say your costs are going to behave normally, what that means is you're going to be able to estimate what your variable cost per unit is and what your fixed cost is. So if we normally make 2,000 bikes a month, then we can be like, all right, our fixed costs are, and we can have a dollar amount, and our variable cost per unit are. So if we normally make, I don't even know what I just said. Ooh, my brain's not working very well. If we normally make 2,000 bikes a month, then I can estimate my costs within that relevant range. But what if I say, what if you make 500,000 bikes? Then you'd be like, wow, I need more factory space. I need more of a lot of things. I need to hire more employees. So your costs are going to behave normally within the relevant range, but outside of the relevant range, like if I ask you to go from 2,000 bikes to 500,000 bikes, then you could be like, you know what? I don't know what my costs are going to be. I'm going to have to re-estimate everything. So this is your normal range. So it's your normal range. And so within the relevant range, so we can't predict costs outside the relevant range because I would have to re-estimate everything. But within the relevant range, your selling price is going to stay constant. So if we sell our bikes for $100 a piece, that's what we sell bikes for. Our fixed costs will remain constant. So our fixed costs are 9,000 rent or whatever. And our variable costs are going to stay constant as well, like 2 cents a gallon on our water bill. So these things stay constant within the relevant range. So total fixed costs, 9,000 a month rent. Variable costs per unit, 2 cents a gallon. And the selling price per unit will all remain fairly constant in the range. Okay, but when you move outside of the range, it will not behave normally. Okay, so there's 3 different methods to come up with your y equals mx plus b. Our y equals mx plus b for our salary was here. Our y equals mx plus b for our water bill is here. But there's ways to do it. And so if I just asked you, like, so my little brother runs that body shop, and if I just walk into his business, like I did walk into his business on Friday, he's up in Kansas City and we were up there for a wedding. And so I just wandered in, and if I just said, Eric, what's your cost equation? He'd be like, what? I don't know what you're talking about. Right. So he's a finance guy, but like, I don't think he'd be like, I don't know. He wouldn't be able to come up with that. But I could take some data from him. And I'm like, all right, do you know your total cost in the month? And he could say, yeah. And I said, do you know the total number of jobs you do in a month? And he said, yeah. And I could go ahead and I could do some estimates based on his normal months of what I would expect his fixed cost to be from month to month. And every time he does a job, about what it costs. Now I know every job is different, and that is how it's going to work. When we do chapter 3, we're going to look at different costs for different jobs. And so right now I'm overly simplifying things, but I could come up with some data. And so if he gave me his data for the last 24 months and I made a spreadsheet and I said, okay, in a month where you did 182 jobs, your cost was this. And in another month where you did 242 jobs, your cost was this. And I could do all of those and I could help him come up with a cost equation. So this is called the scatter graph method. So the scatter graph method basically is you just plot all of the data points. So in this example, I have 3 years of data, almost 3 years of data. I don't have the 4th quarter of year 3. And so I have the number of orders and the billing costs. So when I had 1,500 orders, then this was my billing cost. So it looks like it was about $42,000. Okay, so there's that data point. But then when it was 2,000 orders, the cost was 4,800, 40,000. So you see how we can look at every single data point. And what we see, ignoring the line, pretending the line's not there, what I would say is that I see the lines, the dots, moving in a linear fashion. That's a weird thing to say, right? And I'm not a math professor, but I used to teach intermediate algebra and I love it. Okay, so what I see here is the dots moving in a fairly linear fashion. They're increasing as more orders come in. More orders, more cost. More orders here. When there was 1,500, it was 42,000. But when it was 2,800, it was 54,000. I noticed that it's not purely variable, Because if it was purely variable, then if I had 1,500, then it would be 42,000. And if I had 3,000, it would be 84,000. And there's nothing anywhere near that. So it's not all variable. I see that there's actually some fixed costs involved. And so what I would do though, is I would put my dots in and then I would just slap a line up in there. That's called the quick and dirty method. I swear that's a book method. The author of the book that I used to use for this class, his name's Garrison, and he called the method the quick and dirty method. But what you would do is you would just ignore all the dots and you would make a best fit line. You would just slap a line up in there. And when you do that, some of the dots are going to be above the line and some of them are going to be below the line, but you just guess and make a line. And that's called the quick and dirty method. So that's one way. But another method is called high-low. And so quick and dirty is just basing the line on the scatter graph. And so there it is, and it's done, right? And so the next method we're going to use is high-low. So high-low method, what you do is you just take the highest point and the lowest point and you connect the dots. So this one is the lowest one and this one is the highest one. So the line would not be the same as the line that's currently in there. So we would just take the high point and the low point and we connect the dots and we create that as my cost equation. So let's practice doing that method. So you need to use normal data. So for one thing, I would say that like if there was a month, like here at Friends, if we were doing this and we had like the number of credit hours and the total cost and we were trying to figure it out, and 1 month the boiler broke and we had to spend $500,000 to buy a new boiler, that would be not be a normal month. So I would not use that one to come up with my cost equation because that's not normal. So I would take normal data and I would do this. And so the advantages is it's really easy to do because you just take the data and you pick the high one and the low one and you make the equation. But you're using old data and you're only looking at 2 data points. You're not looking at any of the other ones. So you're basically ignoring every other dot except for the highest and lowest. And that's a little bit sketchy because if this lowest one, like if the range was a lot bigger and these dots were all like in a straight little line, but then this one was a little off kilter and this one was a little off kilter, then it would really mess with things. So you want to use regular data, high, low. So the way we're going to do it is we're going to do y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. And I'm going to show you how to do that. And that's going to give you your M or your slope or your variable cost per unit, 2 cents a gallon on your water bill. And so what we're going to do is we're going to pick the highest and the lowest, and we're going to plug in and do y2 minus y1 over x2 minus x1. Once we know the M, we'll have the M, and we'll take either the high road or the low road, and we'll know the X and Y, and then we'll solve for B. So this should be shifted over there. That should be shifted over there. There. That's what it should look like. Sorry about that. And so, so here we have Y equals MX plus B. I'm going to do this real quick. This is the unfilled in one, and I'm going to fix that real quick because it's bothering me. There we go. Okay. All right, back over here. So the next thing I want to do is I want to take this data and I want to use the high-low method, and I'm going to show you how to use the high-low method. When you go to do your homework, you're going to have to do the high-low method. So this is a great example. So the first thing we have to do is we have to figure out the low and the high. So before you start doing the high-low method, you need your highest and your lowest. And you're looking for the highest and lowest of the meals served. So the X, because activity drives cost. Whatever number of meals you have creates the cost. So more meals, more cost, less meals, less cost. But what I see is this is apparently the lowest month. May, we only had 1,000 meals. So this is the lowest. So make a big circle around the whole thing. Circle the 1,004 and then circle the 10 and 19.5. So this one is your lowest and this one is your highest. So what we're going to do is we're going to use that data and we're going to find our M. So when we find our M, I want little m, equals, and so we're going to do y2 minus y1 over x2 minus x1. So 19,500 minus 4,000. Y's are always dollars. Y2 minus y1. So take the bigger one minus the littler one. Our number is always going to be a positive number. So we're going to take 19,500 minus 4, and then we're going to divide by x2 minus x1, 10 over 1, 10 minus 1. Okay. And then let's see what our answer is. 19,500 minus 4,000 is 15,500 divided by 9. Okay. So 1.72. Oh, I wish it was a pretty number, but it goes 1.7222222. Okay. So that is your variable cost per unit. It's your M. Okay. So we found our M. And now what we do is we use the high road or the low road. Okay. So you use your high numbers or your low numbers, not both, not a little bit of both. The high cost goes with the high units and the low cost goes with the low units. So I'm going to go ahead and I'm going to do both. Is there something written in there? Oh, darn it. Here, let's delete it. Okay. Oh dear. I don't know what's happening. Oh my gosh. Some things went crazy. Okay. So what I want to do, okay, is if y equals mx plus b, if y equals mx plus b, then I know m is 1.72 because I found it. M is 1.72, and I know that. So I'm going to plug in either the low numbers or the high numbers and solve for b. So let's use the high numbers first. The high numbers are 10,000 and 19,500, and I need to know which one is y. I labeled it this time, but y is always dollars. So I'm going to use 19,500 equals m, which is 1.72. And my x that goes with 19,500 is 10,000 plus b. And I don't know what my b is quite yet. And so I need to solve for b. I have one unknown. So algebraically, this is going to go well. I'm going to do 19,500 equals, and then 1.72 times 10,000. We'll just do 17,200 plus b. Now, I know your answer will be a little different rounding wise. On your homework, you won't have rounding issues. And then we would subtract 17,200 from both sides. And we would get b equals. So if we go ahead and underline that, trying to do it like you would have done it in math class. So 19,500 minus 17,200 is 2,300. So 2,300 equals b. So now I found my b. Okay, so the cost equation, just so you can show it then, would be y equals 1.72x plus 2,300. And that is the answer. That's the cost equation. Okay, so when you write a cost equation, you should write it as a y equals mx plus b, and you should show your m and your b that you found using your cost equation. So let's do the low road just so we can see the low road. Right. And so when we do the low road, we will say y equals, I know what y is. So the low numbers, 4,000 equals 1.72 times x, 4,000, 1,000 plus b. And then we would say 4,000 equals 1,720 plus b. And then we would subtract 1,720 from each side. And then we would say that 4,000 minus 1,720 is 2,280. So 2,280 equals b. Now, I know that that's a tiny bit off from the 2,300. It's a rounding thing, okay? But you'll get the same answer when you get your b, whether you use the high road or the low road, okay? So don't use any other data points. Use either the high or the low, okay? So, okay, so let's do another example, and let's find the cost equation for this one. So go ahead and hit pause, and I want you guys to try to go ahead and figure it out. So hit pause, use this data, find the high, find the low, find your M, solve for B, and write your cost equation. Okay, so everybody pause me and then come back. Okay, so this looks like the lowest, and this looks like the highest. Okay, And so to find my let's make that, here. That might be the right answer. Okay. Okay. So let's go ahead and say, M equals, I want my M to be little. It really bothers me when it's not. Let's do, so change in cost, Y2 minus Y1. Now students are tempted to do this backwards, and you may have, because you paused me, right? And so you may have accidentally done it backwards, but Y's are always dollars, Y2 minus Y1. So I need the 2,200 minus the 1,900 divided by 20,000 minus 14,000. So my number is going to be really small. So 2,200, and when I make the students do it in class, they're always like, I got a really little number. I'm like, you're fine, keep going. So 300 divided by 6,000 is 5 cents. Okay, so that's your M. Your M is little. And then I'm just going to use the high road, but if you use the low road, you should get the same answer. So if Y equals MX plus B, then I would plug in what I know. So if I use the high ones, I'm going to use 20,000 and 2,200. So 2,200 equals 0.05 times 20,000 plus B. And then I'm going to solve. And I would say 2,200 equals, and I'm going to take 0.05 times 20,000. And then I got 1,000 plus B. And then I would subtract 1,000 from each side. And I would say that 1,200 equals B. Okay. If we did the low road, just so you can see it, then I would say 1,900 equals 0.05 times 14,000 plus B. And then I would say 1,900 equals 0.05 times 14,000. It should be 700. 700 plus B. And then I would subtract, oh no. Subtract 700 from each side. And then I would get 1,200 equals B. So my cost equation, my answer, Y equals 0.05x plus 1,200. That's your cost equation. That cost equation is what we're going to use to predict cost. So I could say, well, what if next month we have 16,000? Oh, that's what this one says. Haha. Okay. So what would be the expected power cost of machine hours for 16,000? So if we were trying to plan for October and we're like, well, last October it was 16,000. So let's guess on 16,000. So then what we would say is we would just plug in 16,000 in for X, because machine hours are X and dollars are Y. So what would the Y be if your X was 16,000? So you would take 16,000 times 0.05 and you get 800. And then you add 1,200 to that and you get 2,000. Let's see what's under here. Good. Okay. So you just take Y equals MX plus B and you plug in for X, you plug in 16,000 and then you solve for Y and you get 2,000. Okay. So, all right. Excellent. You'll do that for homework a couple times. Okay. So the quick and dirty method, you just kind of throw a bunch of stuff in. That's fine. Okay. So the quick and dirty method is you just graphing it and then slapping a line in there. So what we're going to do now, our last method is called the regression method. And so we're almost done. Oh my gosh, this video is taking forever. So the least square regression method, this is a statistical method. So those of you that have had stats, which everybody in the business program takes stats, you don't need to know anything about stats to be able to do this, because I'm going to show you guys how to do it in Excel. So Excel is like one of my favorite things ever, because it makes everything that's complicated just easier. And so I'm going to show you guys how to do regression using Excel. And so this is a graph. This is a picture that I pulled off of the internet, and it's talking about like what regression literally does. So what it does is it takes every single data point. So the data points are these little orangish dots. And what it does is it creates a line that minimizes the error. So the error is the distance from the dots to our cost equation line. And it makes the best fit line ever. So it takes the data and it creates a best fit line. And then it'll tell you the equation of this line. Okay. So that's what regression does. So we're going to take the data that we've been using. And so what I want you guys to do is, and I want all of you to do this. Okay. So I make my students do it in class because I want them to try this themselves. Okay. So what we're going to do is we're going to take this data right here and we are going to put it into Excel. So open up Excel and type the data in. So I'm going to put meals, which is X, and I'm going to put total cost, which is Y. And then I'm going to put, oh, I need a column here because I'm going to put April. It's not how you spell that word. April, May, June, July, August, September. Okay. Make that a little bit bigger. To make it bigger, I just go between where there's that little line with the arrows that go this way and double click. And then I'm going to put in all my data. 4,000, 1,000, 3,000, 5,000, 10,000, 7,000. And then I'm going to come over here to Y and I'm going to say 9,500, 4,000, 8,000, 10,000, 18,500, and 14,000. Okay. All right. So I'm going to go ahead and move those over to the right because they're kind of bothering me. I'm looking at my data. I'm going to make it bigger so I can see it. You can pause so you can catch up with me, but all I've done is just type this data in here. And so we know that we did this cost equation using high-low. And I think we got 1.72. We got 1.72 and 2,300 or so. So it was about 2,280 or 2,300, somewhere in there. I can just average them and use 2,290. I don't know. But this is what we got when we used high-low. So now I'm going to take this exact same data and I'm going to use Excel. And I'm going to find it using regression. Okay, so there's three things that I'm going to find when I'm doing regression. I'm going to find the M and the B and something called the RSQ. So the M is your slope and your B is your intercept, right? So your M is your variable cost per unit and your B is your fixed cost. And then your R square is going to be the accuracy of the line. So right now I have my data typed in here and I hope you guys do too. I have all my data in here. And then I have M, B, and RSQ. So M, I'm going to go to the cell next to it. So I want everybody to do this. I went to the cell next to it. So I'm just in this blank cell and I'm going to insert a function. So when you insert a function, sometimes it comes up a little bit differently. Okay. So it's a statistical function. I'm using regular desktop Excel. So that's the version of Excel that I'm using. It's just the Excel desktop. But if you're using like Excel, like Office 365, it might come up a tiny bit different. But if you're using a MacBook, it will definitely come up different. But what you want to do is you want to insert a function. So I hit this little F of X button right here. You can also go to the formulas and insert a function right there. But I always just hit that little button right there, insert function. And when I do hit that button, then this little box comes up. And what I'm looking for are a statistical function, but the name of the function is called slope. So slope, search for a function. I'm going to type the word slope and then I'm going to hit go. And it gives me three choices: slope, linist, and intercept. I don't know who linist is. I feel like that's like Charlie Brown or something. So slope, and I'm going to hit OK. All right. So I'm going to do that again, just in case. I inserted a function. So I'm just in any blank cell. I'm in the one next to the M because this is what this one's going to be called. So I'm going to come right here and I'm going to insert a function. And then where it says type a brief description, I'm going to highlight that and I'm going to write the word slope. And slope is the name of the function you need. Okay. And that's like the slope of the line. That's going to be our M. It's going to be our variable cost per unit. So hit OK. And when I hit OK, my box is in the way. It's in the way. But you know what? I can just click on it and move it around. Okay. So I'm going to move it out of the way so I can see my data. Okay. And so what it's asking for is known Y's and known X's. So it wants to know where my Y's are. And I know that these are my Y's because it's the Y column, right? And so if I didn't know, it would be the ones of dollars. And what I want to do right now, I have a fat plus. Do you see my plus, how it's fat? Now it's an arrow. Now it's a fat plus. And then when I start selecting it, I'm going to click and select all of them. And when I go to click, my box disappears. Don't panic. Just select your Y's and then let go. Okay. And so if you're using the function and this box doesn't show up, then you need to put a comma to go to your next field. We are just going to move down one. Move down one, and now it wants my known x's. So go over to your x's. Right now it's a fat plus. Click, drag, let go. And those are my x's. So now it's giving me my m. This is the best m possible. This is the perfect m for all of my data points, minimizing the error. And my m is 1.68. Okay, so that is your slope. Okay, so that's the name of that function, your slope. I didn't have to find the high, find the low, ignore all the other data points, do y2 minus y1 over x2 minus x1. All I had to do was in Excel, use the function called slope, select my y's and select my x's. Okay, so now let's find our b. Our b is called our intercept. So our intercept, we're going to go f of x. I saw that one earlier. We're going to go f of x and we're going to look for the word intercept. And now I have 4 choices: intercept, linest, slope, logist. Sounds very mathy. Intercept. Okay. And it wants known y's and known x's, just like last time. So I'm going to come over here. I'm going to select my y's. I'm going to move my cursor and select my x's. Okay. So now I know my intercept. That's my b, 2433. So my cost equation is y equals 1.68x plus 2433. And this is the best equation based on all of the data points. So this method is by far the best method. And so it's the most accurate method you can use. Okay. So then instead of only looking at highest to lowest, we looked at all of them. So this last thing is called the RSQ. And so the RSQ, that's the name of the function, and it's going to be the accuracy of the line. It's going to give it a grade, like an A or a B or a C or a D or an F, okay? It's going to give you a number between 0 and 1. The closer you have to a 1, the closer you have to 100%, the more accurate it is. So this is going to tell us how good of a line it is. If we were to look at these data points, like just to show you, if we were to look at these data points, they would look like this. That is good looking data. Those dots are definitely moving good. So I think our RSQ is going to be good. Okay, so I'm going to put my cursor right here. I'm going to insert a function and I'm going to look for RSQ, and it brings it up. And it says, like this right here, it says, I'm going to close my eyes, returns the square of the Pearson product moment correlation coefficient across the given data points. Like, what a weird thing for me to memorize. Like, that was close. I don't know why I know that. Like, I think I've just read it out loud enough times that it has kind of stuck with me. But all it really is doing is showing you the accuracy of your line. So hit OK. And just like before, it wants your known y's and known x's. So come over here, known y's, come over here, known x's. And it looks like our line is 99% accurate. What that means literally is that we can predict with 99% accuracy what the cost would be if we know the number of meals served. That's impressive. So 99% of the cost is based on meals served. And we can predict that accurately, which is ridiculous. In real life, that never happens. So that is how you do regression. And this is the best method you can possibly do. So let's come over here. And so I went ahead and showed you the intercept, the slope, and the R squared. The fixed cost is there for 2433. By the way, you guys will do that for homework a couple times just for fun. And it's $1.68 per meal served. Okay, so $1.68 per meal served, 2433 in fixed cost, or the cost equation would be y equals 1.68x plus 2433. This is just so you have something written in your notes, so you kind of know how we did that. So R squared is A. And the reason, like the way that it's actually worded in statistics is a measure of the goodness of fit. So, but we're just going to put measure of accuracy. So accuracy. Okay. But in statistics class, it'll say a measure of the goodness of fit. That's just how good of a fit is the line. So 99%, it's a very good fit. Okay. So, so I'll give you guys a homework preview video to kind of help you guys through. But that's it for chapter 2. I hope that you guys learned a lot from this. This is great information for businesses, for small businesses to understand about themselves. And so this really is a very impactful chapter. So I hope you guys are doing well. Welcome to Managerial Accounting. I'm super excited to teach you guys. I'll see you later. Bye-bye.